What we're going to talk about today is some of the common mistakes that I've seen my students, especially in VHDL classes. Some of the things that are kind of hard to figure out when they first start learning the language. And honestly, a lot of it comes from the fact that people will have training in languages such as Java, C, C++, and it's the sequential nature of the way that things work in the programming languages versus the HDL languages where everything is parallel. So, for instance, here we have just as the architecture of some entity. Okay, so it's architecture behave of E1, which is the entity, and you'll see we have begin end. And now inside of this VHDL architecture, we've got three statements. Okay, so D gets assigned B and C. C is A or Z, B is Z or Y, right? And so if you just think of this thing as a standard programming language, you would think that these statements are executed sequentially, but they're not. What happens is that each of these statements acts kind of like a little process where the inputs, for instance, in this statement right here, would be B and C. And then when there's an event on B or an event on C, then this statement would be executed, and it would calculate the value for D based on what the current values of B and C are, and then assign to D. Okay, so that's all pretty straightforward, but the key thing here is that the statements are not executed sequentially. They're executed whenever excuse me, one of the inputs on the right hand side, for instance, B changes from 1 to 0, 0 to 1. That's effectively an event.
Let's open up the example in EDA Playground then and see what we can see. Alright, so here I have the design in EDA Playground, and as you can see, so let's just take a quick look at EDA Playground. What you have here is you can specify what kind of a language you want to run in, you can specify what tools, libraries, etc., what tools you want to run. In this case we're using the OLDEC Riviera tools, and then you can specify a number of switches and things like that to the simulation. The actual tool then has two main windows. Okay, this one over here on the right is where you would put in your design, and so you can see we've got the statements that we saw earlier which have our design. Okay, the three basically concurrent assignment statements within an architecture, just like we saw in the slide. And then on the left hand, this left window here is where you would put your test bench. So this is where you actually create your test bench code. Now, EDA Playground is not meant to be a full production kind of environment where you're going to do real work. It's meant to be able to try things out. You can try different constructs. You can try different language features, things like that. But it is fully featured from a what it actually will allow you to do from a language point of view. So in this case, we've got our test bench entity. We've got an architecture of our test bench, got some local signals. We've got a component declaration for the design that we're actually going to instantiate. And then here's the design instantiation itself. And then, as you can see, we set all the signals to 0. We wait for 10 nanoseconds. And now we update the signal A and Z to be a 1. So if A changes, then C is going to change. Z changes, then B is going to change. So those changes then will affect what happens on D. And again, these statements are not sequential. So even though we're changing the values for statements lower in the design here, lower from a sequential point of view of the statements, what you're going to see is that indeed the design does actually function irrespective of the order of the statements. So I just ran the simulation, it compiled it. We look at the waveform display. Yeah, we changed A at time 10, we changed Z at time 10, and as you can see, the output actually reflects the fact that the output is updated based on the input values that we gave it, irrespective of the order of the statements, because they don't matter.
But what about if we go to a process statement? Okay, so now a process statement is just the opposite. All of the statements in our process statement are actually sequential. So if we take that same design now and we put it in our process statement, it's going to execute this statement first, then this one, then this one. Okay, and so and then of course the values there then are going to be assigned to the outputs. Okay, at the end of a delta cycle. So we're going to go through what is a delta cycle, because that's one of the things that really confuses people who's just starting out in VHDL, especially if they just come from a programming language. All right, so one other little point on this is that in this process, you'll notice that we just have what's called Z and Y in what's called the sensitivity list here, which means that only when Z or Y has an event, changing 0 to 1, 1 to 0, do we actually execute this process. So if there was a change on A or X, this process would not execute. So it would effectively ignore that value. So what you have to do when you've got a bunch of statements like this is you have to put all of the signals on the right hand side into that sensitivity list to make sure that the process actually does what you would expect. Because what's going to happen is, let's say we change Z, that will, the first time through, none of these statements are going to change any value, because they will execute, but they will not change value, because B, C, A or X has not changed, but Z has changed. So at the end of the first time through, basically Z, the change in Z will update the value of B. Okay, since B is in the sensitivity list, once it changes, this process will execute again, and then it'll take the new value of B and assign it to D. Use it to assign the new value to D. So, but the key is that the signal values are not updated. Well, so once I do this assign, it doesn't happen right there. It doesn't happen immediately.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. You can watch the rest of Doug's webinar, Common Mistakes in VHDL, whenever you want, by heading over to our website www.doulos.com/OD and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.